Today's objective is I will be able to write and evaluate numerical expressions in exponential form using product, quotient, power of product, so everything we did yesterday, and then adding on power of a quotient, zero product property, and negative exponent rules. If you do not have your orange paper with you, that is okay, but you should be taking notes either on the computer or on a piece of paper yourself because you will need to be turning those in, and you will need to transfer that to the orange paper when we get back into school tomorrow. All right, so last thing we did was power of a product rule, and I think what we came up with was keep the base and distribute the exponents. So when I have power of a quotient, it's not much different. If I were to expand this, I would get 4/3 over 2 to the 5th times 4 cubed over 2 to the 5th times 4 cubed over 2 to the 5th. And then if you remember how to multiply exponents and fractions, we just multiply straight across. So the top stays 4, and I add the exponents. 3 plus 3 plus 3 is 9. And I same with the bottom. I keep the bottom, and I add 5 plus 5 plus 5, which is 15. So if I look at this, I can just keep the base and distribute the 3 to both the exponents, everything inside the parentheses, and multiply. So this becomes 4 to the 3 times 3, which is 9, over 2 to the 5 times 3, which is 15. So that is my answer. All right. Please write this rule in your own words. So you should pause the video and come up with a rule in your own words. All right, so you should have said something along the lines of like keep the base and distribute the exponents. All right, so when I have one like this where I have multiple things I need to do, all right, I like to think of it as order of operations. And so order of operations tells me that I always do parentheses first. And so in order to solve this, I'm going to do everything in the parentheses first, and I'm going to simplify this so then I don't have as much to deal with. Like I don't have to distribute this to 4 things. I'll only have to distribute it to 2 things, and it gets a lot less messy and a lot less big numbers. So if you remember our quotient rule, we keep the base and subtract the exponents. So if I'm looking at the 5s, I keep the 5, and I subtract 3 minus 1, which is 2. Then if I'm looking at my 7s, I keep the 7 and subtract 4 minus 3, which is 1. So I can either write the 1 there or not have that, and then all of that is in the parentheses to the 5th power. Then I take my power of a product rule, and I keep my base and I distribute the exponent. So I get 5 to the 10th times 7 to the 5th. Now, again, we could have distributed this 5 to every exponent, which would have given us 5 to the 15 times 7 to the 20 over 7 to the 15 times 5 to the 5th power. And then again, I could have just subtracted 5 to the 15 over minus 5 is 5 to the 10th. And then 7 to the 20 minus 7 to the 15 is 7 to the 5th. So like I get the same thing. Just when it gets to a lot of different things, I always like to try and start from the inside out so I don't get so confused. But again, it's up to you, which you like to do more. All right, so we have done power of a quotient, so now we're moving on to the zero product property. So if I were to simplify this, like if I were to do our quotient rule, I keep the base and subtract 6 minus 6, which is 0. Okay. If I were to expand this, I would get 5 times 5 times 5 times 5 times 5 times 5 over the same thing. 5 times 5 times 5, 6 times. Okay. If I were to simplify what I have here, all right, my 5s can cancel because those would technically make 1. And I would keep doing that until you should notice that every 5 is going to cancel because there is the same amount of 5s on top as there are on the bottom. And so therefore, because of that, really 5 to the 6 over 5 to the 6 is the same as saying 1. So when I have 5 to the 0, that's the same as saying that equals 1. So if I think about it, 3 over 3 is 1. 100 over 100 is 1. Anything divided by itself will always be 1, and that is the same case if it has exponents or not. So that equals 1. So our rule that we should write is anything to the power of 0 is 1. And that includes anything, no matter what. So like this number, I think it's 10 million. Okay, 10 million to the power of 0 will always be 1. Anything to the power of 0 is 1. So 4 to the power of 0 is 1. This one, however, is not 1. So my rules with exponents is that my exponent is only on the number that it is right above. So like right now, this 0 is only on the 3. It's not on the 9 and the 3, it's only on the 3. So because of that, 3 to the 0 becomes 1, and I still have this 9 out here. So 9 times 1 is 9. If it were 9 times 3 to the 0, then that would be 1. But because the 9 does not actually have a 0 exponent on it, the answer will be 9. All right, our last rule is the negative exponent rule, which is probably the hardest one to understand. So, when we have this, we have 5 to the 6 over 5 to the 9th. So I take it, I keep my base, and I subtract my exponents. So 6 minus 9 is 5 to the negative 3. Okay. However, we cannot have negatives. So there is a rule that I'm going to teach you shortly about what we do when we have negatives. But if I were to expand this, which I don't really want to write this that many times, but it's okay. I would get 5 times 5 6 times on top, and 5 times 5 9 times on the bottom. Sorry, they're getting messy. Okay, if I did the same thing where I start canceling things out, it's 4, 5, 6. Notice everything is canceled out on top, but I still have 3 5s on the bottom. So technically I have 1, because if everything canceled out on top, there's a 1 there, over 5 cubed. Okay, so 5 to the negative 3 is the same as saying 1 over 5 cubed. So anytime you have a negative exponent, you need to move it to the opposite side of your fraction. You can come up with some way of saying that because I'm not 100% sure the best wording that will help you, but maybe after we do a couple more examples, you will come up with good wording. So you cannot have negative exponents. It's like a rule. So 5 to the negative 3, like I said, is 1 over 5 cubed because we're taking this, and right now it's technically on top of a fraction, and we're moving it to the bottom. This one, however, the negative exponent is on the bottom of the fraction, so I just need to move it to the other side. So instead of having 1 over 4 to the negative 2, I can just say I have 4 squared because it was on the bottom of the fraction, and then I'm moving it up to the top to make a whole number. Again, 4 to the negative 7th is 1 over 4 to the 7th. And then this one, the negative exponent is only on 6 to the negative 2. So I don't do anything with the 5. I keep the 5 on the top of the fraction where it should be. And then when I bring the 6 up here, instead of dividing the 2, I'm multiplying the 2. So it comes 5 times 6 squared. All right, here is your homework for today. You can either put on a separate piece of paper, you write it out, and then you can transfer it to your orange paper. If you have your orange paper, these questions are on your orange paper, I think, most of them. And if you don't have paper or that is not an option, you can also do it on a Google Doc. I need you to submit your notes from this assignment and your homework, these 6 questions, into Canvas in order for you to get the full credit of this homework.